Hey everybody, welcome back to Deterministic. I'm Brandon Konkle, and this channel is where I explore more deterministic, more predictable ways of building applications and services, taking advantage of strategies like functional programming and static type safety to bring more predictability to our applications and more safely handle the kind of chaotic day-to-day issues that we get into as software developers. As our applications become more and more complex, I've definitely found it helpful to adopt patterns and tools that really help you protect yourself from yourself and make it easy to build software that does the right thing and smoothly handles the wrong thing. So it's been a little while since I've been able to put a video out, and that's because my family has continued to deal with some health struggles this year. My wife and my son have had some pretty severe health trouble, and that's where my priority has been. I've been supporting them and making sure they have everything they need to recover and get back to normal. But thankfully, I'm really excited to be able to get back to my series on Nest.js today. Nest.js is a framework, my favorite framework really, in the Node and TypeScript world for building type-safe applications that have a large capability for abstraction, ways to share similar functionality in a lot of different ways, which makes it easier to work with larger teams and kind of share different strategies and patterns with the team in ways that are easy to consume and easy to work with. I've been talking about GraphQL APIs, which GraphQL is my favorite way of communicating with a client and creating essentially contracts with the client that you can fulfill in different ways. But today I'm going to set all that aside and I'm going to step into more real-time events. Real-time is kind of a misnomer. There's always going to be some latency. But when you talk about real-time event handling and event-driven interactions, you're talking really about things that allow for working with a whole lot less latency than the traditional request response cycle kind of affords you. So, you know, in traditional web applications and mobile applications, the client or the browser makes a request to the server and awaits a single response. But as your user interfaces become more and more sophisticated, this becomes less and less practical and more limiting. Your user may expect to see and interact with data that's kept up to date in that near real-time fashion, or they want to interact in different ways where requests and responses become kind of an awkward model for dealing with it. I think messaging services like Slack are a really simple example of this, but as you get more and more sophisticated, as you get into things like gaming and other types of interactions, it really becomes even more helpful to have a way of handling events, sort of similar to how you'll handle events on the front end and in your UIs. Having an event-driven flow on the back end can be really useful for modeling and handling these flows in a more clean and easy way, I think. So, traditionally, WebSockets they're not necessary for this. Since the XML HTTP request thing in a browser, or often your mobile tools are already asynchronous when making network calls, you can enable really simple event-driven interactions with repeatedly calling the server looking for new events. That's typically called polling, and you'll see they'll have like a poll interval where it will call out to the server with that typical request response cycle. The server will respond back with the list of events or the new events or something like that. And so each time you go out and you look for more events that you can then handle on the client side. And this is one way to do this, but it definitely doesn't do much to help the latency problem, especially with your polling intervals. If you want to avoid overloading your server with just repeated hammering requests, then you've got to create a rather sizable poll interval, which increases the latency. It takes longer for those events, once they're published, to be received on your side. So the downsides of polling are generally that higher load on the server and potentially higher latency. It's not an ideal way to handle an event-driven user interface or interactions. So the WebSocket protocol was something that was introduced to help solve this. Instead of being one-way communication where there's a request sent and then a response received, WebSockets are full duplex, two-way TCP connections that are held open throughout the duration of the interaction. They provide a really good way for the server to send or push information to the client without it first being requested, allowing you to embrace patterns where you can have many requests or many events handled. You don't have to have a single request and response. You can listen for things. You can emit events just like you would in a browser or something like that. They work on the same port as HTTP and HTTPS, and they use an upgrade header to take that initial HTTP response and upgrade it to the WebSocket protocol. And browsers and also things like React Native in mobile tools. I'm sure there are other native tools for working with WebSockets in a mobile context. But they allow you to hold that TCP connection open and allow the server to push events and you to push events back to the server. And it really enables a nice interface for working in an event-driven way when you're communicating with the server. Now, that's not the only way to do this, especially in a GraphQL context. A lot of you will be saying, hey, what about GraphQL subscriptions? And subscriptions really are a very convenient way to use that GraphQL ecosystem, use a GraphQL operation to subscribe to a stream of updates from the server. You can use polling or WebSockets behind the scenes to enable this kind of subscription communication. But the downside for the kind of thing that I'm talking about here is that this is still a one-way stream. It doesn't allow you to take advantage of that full duplex two-way capability that WebSocket provides. It's a really great tool for a lot of use cases, so I don't want to discount it at all. But it's not going to handle all interactions. It's not going to handle those more particularly sophisticated interactions where your client may want to emit a variety of different events that the server can then handle and respond to if it wants to. So I'm going to skip over GraphQL subscriptions here. I'm not going to talk about them today. But if you're interested in them, Nest.js does provide a lot of great support for GraphQL subscriptions. Other frameworks out there, Apollo does a good job. That's what Nest.js's GraphQL support is built on. So if you don't need the two-way communication, look into GraphQL subscriptions because they really are a convenient abstraction around all these things. But I'm going to talk about WebSocket itself because Nest.js does a pretty good job of supporting WebSockets in a not conveniently abstracted way within the framework. So to get started on how Nest.js specifically supports this, we'll talk about gateways. So gateways is really a Nest-specific term for a controller that handles WebSocket events. So it's kind of just like how a GraphQL resolver is like a controller that handles GraphQL operations. So the gateway in Nest.js is their terminology for a controller that handles WebSocket events. And it's somewhat abstracted. You can use Socket.io, which is a really popular and long-running implementation of WebSocket in the Node world. But there's also, you can use the WS library, which is a more kind of standards-based approach because Socket.io grew before there were really solid WebSocket standards. But the WebSocket, the WS library is kind of closer to the standards. I like Socket.io though because it provides a lot of conveniences, especially on the client, for handling the kind of typical interactions that you would have in a WebSocket-driven event handling or event-driven kind of flow. So I am going to share my screen here and talk a little bit about how Nest.js gateways work. All right, there we go. All right, so I've got my Nest.js example caster API project pulled up here. And like we've talked about before, this is a project that implements an application for web podcast hosts. Podcasts or live YouTube shows or, anything where you've got a host with episodes that feature guests that talk about topics. That's essentially what this application would do. Is it would hypothetically enable that kind of show host communication as they're conducting their episode, and the WebSocket capability here would come into play when you've got a group of people, the show host and guests, who want to talk about topics during their episode. So they've got their episode pulled up, they've got all the details of the episode, all the topics that they want to talk about in their episode, and this would give them like a back channel chat communication layer where they can chat to each other while they're running the show, point things out, almost like a Slack back channel would be, or something like that, around this application. So in Nest.js, I've got things broken up into, this is actually something that NX provides, apps and libs. And so I've talked in previous episodes about how apps are like your entry points. In my case, I've got my API app, which is my entry point to the libraries that deal with shows and episodes and events and users and things like that. So my API entry point, my API app, it uses this app module to kind of pull together all the dependencies, all the things that it needs to launch the app and start handling the requests that it needs to handle. And so we've talked about how we're using Prisma for, using Prisma for things, handling database connections and interactions. We've got the GraphQL module there that's establishing all the resolvers that use services to handle requests. We've talked about the authorization module and the roles module that help you define who can do what in your application. But today we'll pull up the events module here, which pulls together the gateway from the Nest.js framework and connects it to an event bus. And in my case, the event bus is Redis with their pub sub channels. But I'll go into Redis a little bit later. First, I'll talk about this controller layer that Nest.js provides for handling events. It's really similar to the layer that they provide for microservices when you have like a CQRS style or event sourcing style set up for speaking to different microservices through events. But gateways in particular are, instead of ways of communicating between multiple server processes, gateways are ways that you can use an event-driven model to communicate with your client. So, like I said, you can use Socket.io or WS, the WS library for working with these events, listening to these events, establishing these connections and everything. And gateways are Nest's way of pulling that all together. And they've got a pretty neat decorator strategy for defining methods that handle different types of events. So you can see I've got the events module pulled up here, and first you'll see a Redis provider here. We'll talk a little bit more about this in a moment, but the thing to keep in mind here is that a Redis instance can either be a subscriber or a publisher, not both at the same time. So I've got a Redis provider kind of abstracted away here that uses the use factory function to inject the config, which we've talked about in previous episodes, but that's the Mozilla convict library for working with application config in a variety of different ways, environment variables, files, etc. It's going to inject this config and use it to find the Redis URL. And it also gives you this event options input that you can give it to override that URL if you want to point to an alternative Redis location or something like that, to give you a little bit of flexibility. But the way that this works is the use factory function just returns a new IO Redis instance. I love the IO Redis library for working with Redis. It's really convenient. But it creates a new instance of that library with either the overridden URL or falling back to the config URL, the redis.url property that convict provides. So you can see my actual module down here is a little bit weird. We've talked about this, I think, in other episodes, but it has kind of a static portion of the module here, which provides the console logger, provides the event gateway and the channel service for talking with Redis. But then it also has a dynamic portion here, allowing you to pass in that overridden config or something like that. You can get a lot more sophisticated with this, but this allows you to kind of set options at runtime when you're firing up your application. So this for root method here, that's a convention in the Nest community that talks about this is a module that's intended to be established at the top level of your application and shared across all of the things provided inside it. So when I'll flip back to the app module here, when I call events module for root, that's intended to be in this top level application module, and it establishes the events gateway that's shared across the entire application. You'll see I'm doing two Redis providers here, one using the default subscriber mode, and that provides this subscriber. It uses this injection token, which I'll click into that really quick, but this is a simple strategy that I use to kind of indicate what this injection token is for. This injection token is basically just a type that takes a string, but allows you to encode what it's injecting. So in this case, it's injecting a instance of the Redis class here. So my subscriber injection token and my publisher injection token are intended to wrap around the same thing. It provides the same thing behind the scenes, that Redis class, but in different modes. Like I said, we'll talk more about Redis later, but let's look at the event gateway here that it provides as part of the static part of this module. This events gateway, I'll click it open here. You can see it makes use of the channel service, and the channel service is what's pulling in the Redis instances behind the scenes. But it provides a couple of methods here. A couple of extra methods too that I forgot about. But we've got the client register and message send methods, and you'll see they're decorated with this subscribe message decorator that comes from the Nest.js WebSockets library. And this subscribe message allows you, gives you a really convenient way to indicate, hey, this method is an event handler for this type of event. So before I dive into the method itself, let's look at the event types and some of the different types that I've got set up for this module in general. So you'll see at the top of my file here, I've got a const enum for event types. This is basically just an object with as const that gives it kind of the properties of an enum. Instead of saying client register is type string, it says client register is type actual string value of client register. So it knows what the string value for each of these is instead of just making it a generic string. And then you can use this type of event types, key of type of event types. This little trick here will give you the actual options for what the value could be. It kind of works around some limitations of built-in TypeScript enums in a convenient way. And then you can just refer to those strings by saying event types dot client register, like I'm doing over here in this subscribe message decorator. So you'll see I've got a few different event types. I've got a client register type. I've got a client registered event. So client register is what the client, whether that's a web browser or a mobile application, when it wants to subscribe to a channel for a particular episode. So people are joining this episode. They're going to talk about this episode. They're going to chat about it behind the scenes as they're conducting their podcast or their video or whatever. The first thing that happens is their client registers itself. And this is because I'm designing this API to be scalable. I'm designing it to be horizontally scalable, meaning that we will have multiple instances of this application running on different containers within Kubernetes, or maybe different containers within ECS, or different Lambda functions in a serverless context, something like that. And so you can't expect there to be just one process running all the time that's going to handle all the events and it's going to keep track of who's what registered to what. We need to communicate through a back channel, an event bus. That's where Redis comes in here. And so the client register event signals that, okay, this new client wants to subscribe to the Redis channel that is powering a particular episode's discussion. And the client registered event is an event that the server sends back to acknowledge, okay, you're subscribed, you're good to go. You can start sending messages. And you'll see in the integration testing that I have how it's useful to wait for this registered event so that you can then allow the client to start interacting with the channel. There's also a ping event here, which the client can send periodically to help keep the connection open. Sometimes if connections go stale, it'll get automatically closed by either the browser or the server sometimes. So having a periodic ping helps keep that open. And then you've got the message send event that clients can send, and the message receive event that the server sends back to everyone who received the message that the client sent. And so these are the different types of events that can be emitted on the WebSocket channel, or the WebSocket connection, sorry. You can see the shape of some of these events. There's the client register event here, the message send event. They take things like episode IDs and your profile ID for the user that's connecting or subscribing to a channel. You've got the text contents of a message sent by that subscriber. You've got the message receive event, which is sent from the server to clients, indicating that someone else has sent a message that they will now want to receive. And then I'll skip over this. This is just our injection tokens that we looked at before. And this is a little bit of context that helps with the Redis communication. But this thing at the bottom here, this chat message, this is the internal shape of a message sent on the Redis channel. So this event types up here, these are WebSocket events. And then this chat message here, that's the Redis event that happens behind the scenes. So going back to the events gateway here, you can see there's only two main methods here, client register and message send. Skipping down to this after init and handle connection, these are hooks that Nest.js provides so that I can add a little bit of extra logging indicating, oh, these things happened. But the real action is in the methods that are decorated with subscribe message. So subscribe message says, okay, server, when you get a client register event from the client, if they've emitted this event, then this is the message that, or the method that handles that event. And you'll see we can pull in some of the same tools that we're using with our GraphQL resolvers, things like the app ability that we use with Castle to handle authorization, and the sensor fields function that's automatically populated with the current user. This all happens from that initial HTTP connection that gets upgraded. So Nest.js keeps track of the user that upgraded to WebSocket, and so it allows you to inject things like that user's ability, that user's sensor fields, the socket, the connected socket from that user. You can inject those into your event handlers, and this makes it really convenient to keep authorization and stuff like that the same as with your GraphQL operations that you're handling, or your REST endpoints that you're working with behind the scenes. So you'll see that's the first thing that I'm doing. I'm checking for authorization. I'm checking to see if this user can't read a message, which message is my Prisma model behind the scenes that will keep track of the messages that people send. If we can't read a message, then we shouldn't be able to subscribe to events for a particular episode. So it's using the requested episode ID, and so that allows you to get really granular with your Castle authorization rules and say, okay, this user can only read messages from this episode because they are a member on this show, or something like that. You can handle some pretty sophisticated authorization logic with roles. What is it? RBAC, role-based access control, to really help you get very granular and particular with the authorization decisions that your application is making. And you'll see we're throwing a very particular error here. This is a WS exception. The WS exception is a WebSocket error, and it's different from the errors that you'll throw in a GraphQL or a REST context. And so this brings to mind a little bit of complexity here on guards. You'll notice I'm not using the same guards to enable things like ability and sensor. I'm not using the same guards that I use on a GraphQL context because WebSocket events are a little bit different. So if I pull open the socket JWT guard, You can see it extends the regular JWT guard, but it does a little bit of work to figure out the socket request handshake. That's part of the upgrade event that I was talking about behind the scenes, and pull the details out that you need in order to enable JWT authentication behind the scenes for your WebSocket handlers. But it's extending the JWT guard, and then it's wrapping it with a catch that will then take whatever, HTTP based or GraphQL based exception that the JWT guard normally throws and convert it to a WebSocket exception so that Nest.js knows how to handle it. And so that's what the socket auth guard is doing too for authorization. It's wrapping the regular auth guard, and in this case, it's really literally just doing what the auth guard itself does, and then just catching any exceptions and wrapping them in the WebSocket exception rather than the HTTP or GraphQL exception that it normally works with. So you're not repeating yourself necessarily, you're just extending the resources that you created for normal HTTP interactions to use in an event-based context. So that's what enables things like ability and sensor to work, even though this is WebSocket and not a typical request response cycle. So once we get past that, once we know, okay, they're authorized, they can read messages from this episode, then we're calling the service. This is the channel service that I've established behind the scenes, and that works with Redis to allow your horizontally scaled application instances to communicate on a unified back channel, so that this horizontal, this multiple instances thing works. It's all still funneled through one channel rather than a bunch of different channels that it depends on which server you connected to. A lot of tutorials that I saw for WebSocket in Nest.js completely sidesteps or ignores this issue and assumes that you're just going to have one application process. But in most cases, that's not realistic. If you're handling any kind of scale, any kind of load, then you're going to have multiple application processes. And so you need an event bus behind the scenes to coordinate all this. So the register client, it passes that censor function that allows you to censor sensitive data like an email from a profile if someone's not authorized to view it. And then it also passes in the socket instance, which this is our persistent connection to the client. It passes it into the channel service, and the channel service is responsible for subscribing the user to the channel for this particular episode so that it can send and receive messages on that channel. And that's pretty much all that the register event or the client register method here does. This is the controller method that handles that, and it hands off to the service to do the actual work behind the scenes. And then you'll see the next method here is message send. This uses also that subscribe message decorator, but in this case, it's looking for the message send event instead of the client register event. And in this case, the first thing that it does is make sure that the user has a profile. If someone isn't fully signed up yet, we don't want them sending anonymous messages accidentally or unintentionally. And then we check for authorization based on that episode ID and the profile ID that we retrieve to see if, okay, can this user create a message for this profile? And so this prevents people from spoofing other profiles and sending a message for a different profile ID other than the ones that they have access to. That's part of the castle rules behind the scenes, and it throws that forbidden WebSocket exception if it determines that they can't. But if everything is good with authorization, it moves on to the channel services send message method here, which takes the event, which is the, where did event come from? Yeah, it's the message body from that message, and passes that in along with their profile ID. All right, so there's a lot going on here. There's a lot that this kind of pulls together, but it does it in a way that's really consistent with the other types of interfaces that Nest.js provides, the other abstractions that they provide. It allows you to use the same tools for things like authorization and authentication that you're using for your traditional HTTP requests. And that's one of the things I really like about Nest, this consistency that it brings to the way that it abstracts things. Like I've said before, it's not a perfect framework, but things like this are really powerful. All right, so Nest gateways, like I said, they're like the controllers for event handling, but once you've handled that event and you're wanting to actually send the communication behind the scenes to whatever other services are listening, that's where you need an event bus. I went with one of the more simple event buses out there, but it's still really powerful and really scalable in a lot of ways. It's Redis's pub sub support with channels behind the scenes. So Redis gives you a way to subscribe to a channel so that anyone who publishes a message to that channel, it's broadcasting that message out to an indeterminate number of subscribers. It doesn't know who is listening to, like our server doesn't know who all is listening to this channel. Redis keeps track of that. The server just publishes an event and allows all the subscribers to that channel to receive the event. So in my setup here, my channel service uses a particular channel name for each episode ID. Let's jump into the channel service here. Oh, I don't have my screen sharing, so I'll get back to that. There we go. All right, so here is my channel service. This is what my events gateway was communicating with behind the scenes. And you can see this is pulling in Socket.io and IO Redis to start speaking to Redis behind the scenes to communicate on these pub sub channels and allow whatever horizontally scaled application instances that are out there that are subscribed to this channel and listening for events. It can broadcast to all of them and it doesn't have to know who they are. So this channel service, you can see it injects both the publisher and subscriber instances. I talked before about how those have to be different. And really the only reason for it is that once you set a Redis connection up as a publisher or a subscriber using the IO Redis library, it kind of shifts into whatever mode you've used it in as first. So if you subscribe to something with the subscriber instance of Redis and then you try to publish something, it's going to throw an error saying that this is not a publisher, this is a subscriber. So that's why you need two separate Redis connections, two separate instances here to handle the communication in both ways. And then it also pulls in the profiles service, which is the class behind the scenes for retrieving profiles and things like that. So looking at the register client method here, this is what is called by the client register event handler on the gateway. And this, at this point, once we get to the service layer, all the authorization and stuff like that, all of the things that adapt the request to the underlying business logic of handling that request, they've already happened at this point. The gateway is responsible for authorization. So once you get to the service, you don't worry about that anymore. This provides a consistent interface, even if you're using this in different ways, not just with Nest.js, but with something else too. That's one of the great things that Nest.js does, is it allows you to decouple things in this way and make it easier to share. So the register client method here, it takes the event that was emitted on WebSocket. It takes the censor function that allows you to strip out things like emails for those who aren't authorized to see them. And it takes the socket. That's the connection from the server to the client that is being held open right now. It packages that together in a nifty context object here. And then it uses this .subscriber. Now subscriber is just a Redis instance. And it says on. So this is like the typical event emitter that you'll see in Node. It's used that same kind of style. So it says on message. Message is the event emitted by the IO Redis library when it gets a message back from the channel that it's subscribed to. So on a message, call this .handle message, and it passes in the context. So let's skip over send message here and let's go down to handle message and see what that does. This is a higher order function, meaning it's a function that takes some input and then returns another function. In this case, it's taking the message context that we established as its input so that that'll be available across all the different times that this async function internally that gets returned, no matter how many times that's called, it will still have the context from the outer closure here in JavaScript. That's something really convenient. This it takes that context, it establishes it in the outer scope, and then returns the event handler, which is this async function. And going back up here, that's what gets handed back to Redis to handle these messages. So that kind of basically encodes that context into the event handler to be used across all of the invocations of this event handler. When Redis calls this event handler, it provides a channel and a message, and that can either be a plain string or a node buffer. You work with it the same way, essentially. And then it returns a promise, but it doesn't resolve to anything. It just resolves to void, giving you a chance to throw an error if you need to or whatever, but not actually looking at the response at all. So each time the event handler is called, each time Redis has received a message from the channel that it knows that this subscriber is interested in, we pull out the episode ID, the sensor function, and the socket that we got from the gateway. And then it constructs, or it actually parses the message, which that's that chat message type that we looked at earlier. That's the shape of events that are emitted in the Redis channel. And it pulls out the text and the sender information, which really just has the profile ID in it there. So we take the sender, which is optional. There doesn't have to be a sender there. That's mainly to avoid errors, but you'll see we're doing some error handling here to let the server know, or I guess document the fact that this happened before it bails out and can't handle the message because it didn't have a sender. But in the happy path case here, it uses the profile ID to get the most up-to-date profile for that sender. So it's found the sender, it's not returning nothing and logging an error. So next it checks for the text. And if the text wasn't there, then it also just bails out and says, oh, you know what, there was a message received with no text. We're not going to do anything with it, but you'll see that in your logs later, and you can use it to help troubleshoot issues. And then it censors the sender's profile based on the current user's capabilities. This uses that castle censor function, and this censor function was preloaded by the gateway as part of the auth guard. It was preloaded to have the castle rules that the current user, the subscriber, is allowed to access. And so the censor function says, okay, pass this sender profile, but censor it based on the subscriber user. And so in this case, if the subscriber, if the receiver isn't an admin or it isn't the same user, then it can't have the email field of the profile. And so that's what this censor is doing here. It's saying, okay, if the receiver doesn't have access, then it doesn't get the sender's email. And then it constructs this message receive event that it will then emit on the WebSocket connection. So this takes the Redis event shape and packages it into the WebSocket event shape that our clients are expecting. So there's two layers at work here. There's the client and server communication layer that has its own set of events, and then there's the server and event bus communication layer that has a different set of events that are going to differ a lot in many ways based on how we're working with these events behind the scenes. So it uses the socket to emit the message receive event that then goes back to the client. And so the client knows, okay, I got some chat. I'm going to display this chat with the profile information that I got from the sender and enable this chat interaction behind the scenes of an episode for the podcasters that we're supporting here. So that's how a message is received. To send a message, it's a lot simpler, actually. I'm going back to the event gateway, to the message send method here. It gets the message body and the ability and everything. And then, like we talked about, it triggers the send message event on the service. And really all that does is it uses the publisher instance of Redis to publish a message on the channel based on that episode ID. And it constructs that chat message type that we're looking for internally for events that happen on the channel. So this kind of closes the loop. This is how that event gets published that our subscriber then listens for and handles here. So you can see the different abstractions, the different tools that Nest.js provides here. They really give you a pretty powerful way to handle events, handle these event-driven interactions in an organized and controllable way, a predictable way, a deterministic way. That's one of the things I really love about Nest.js, the tools that it gives you for handling these interactions in ways that are not crazy. They're not hard to wrap your head around. They're consistent. They're predictable. So if you've done any work in event-driven server interactions, you'll know that Redis is certainly not the only way, the only event bus that you can use behind the scenes. And in fact, Nest.js itself provides some pretty strong support for other gateway or other event buses behind the scenes, like Apache Kafka or RabbitMQ or SQS or Event Hub or something like that on AWS. There's a variety of different ways to handle events behind the scenes. And really what it's giving you, something like Kafka gives you much more advanced control flow and protection for all kinds of different things, deduplication, consistency. It gives you ways to manipulate your events and how those events are passed to different handlers in really powerful ways. You can have events that are split up and handled between multiple different types of consumers that are handling different aspects of the event that you've emitted, and you can get really sophisticated and powerful with it. And that's where some of these event sourcing approaches come, where instead of using a database as your source of truth, you use the events themselves as your source of truth. It's a really fascinating kind of field to get into. But for my case, for my purposes here, Redis pub sub channels are a really simple way to enable this kind of event-driven communication. So we've talked about how Nest handles gateways or provides gateways as your controllers around the events, how the event bus is your back channel for communicating those events across all of your instances of your application server. But how in the world are you going to test all this stuff? Testing's got to be really hard, right? No. That's one of the other great things about Nest.js are the tools for testing that it provides. And you can get some pretty rich, powerful testing going here with just the Nest.js unit and integration testing tools that it provides. Let me get back to my display here. And let's first talk about unit testing these things. The unit testing is going to look really similar to the stuff that we've already talked about in testing your GraphQL resolvers and things like that. But the integration testing is where it gets really cool. And then I'll also, before we finish up, do a slight detour and show you one potential way of connecting to this, a web client example of how you work with this, just really briefly. But okay, so for the event gateway, I'm handling testing like I would test anything else in Nest.js on the unit level. I'm using the test module, the create testing module tool here to provide my event gateway. This is the thing that I'm testing, and then dummies, mocks for all the things that the event gateway uses behind the scenes. So the channel service, the user service, the castle ability factory, that's all getting spoofed essentially here with the mock deep tool that we've talked about before from Jest mock extended and injected into our testing module here for working with the event gateway. And it's really pretty straightforward. I'm overriding the logger so that we don't get a bunch of log spam and giving me a way to check for log messages if I want to. But really, it will dig into the describe blocks here and the individual tests. It's really simple. I've got some event factories here to create like the client register event or things like that. And that's really just Faker behind the scenes. I don't know why it's not happy with my event types right now, but my integration tests are working. So I don't know why it's angry, but I'll ignore that for the moment. And these are the different types of events that we can create with the event factory. So you see I'm just passing all of the different pieces in. This ability is my spoofed, my mocked castle ability thing. That's my mocked sensor function. That's a mocked WebSocket socket. And I'm checking to make sure that the event handler is doing what it's supposed to. Did it check for authorization? Did it check for authorization with the right parameters? Did it call the register client handler? Did it call it the right number of times? People skip these to be called times methods a lot, but I found them to be really useful in trying to figure out what went wrong when things do go wrong. I'm checking to make sure that it's handling authorization correctly and throwing that forbidden exception when it needs to. It's handling failed registration attempts where something went wrong when we're trying to subscribe to the Redis channel behind the scenes. And it's really straightforward, just mock checks to see if everything is happening the way that we think it should. Similarly here with the channel service, I've got the Redis publisher and subscriber instances auto-mocked behind the scenes with that jest mock extended tool. And I'm using my create testing module to create the test module and inject everything that I need to work with. And yeah, the handle message is a little bit trickier because of the fact that it's a higher order function that we need to pass in some things. So you can see that the handle message tests get kind of involved, but really at their core, it's the same thing. It's checking to make sure that mocks have been used the way that you expect them to be used, and faking responses back to enable the flow that you're trying to test here. So yeah, the unit testing is pretty straightforward, and that's a great thing about Nest. Unit testing is typically pretty straightforward with Nest. But how in the world are you going to integration test all this stuff? Integration testing is not necessarily the same as end-to-end testing like we've talked about in a previous episode. End-to-end testing would be including the client in all this. So it would be using something like Cypress or mobile testing tools to actually interact with the client in a way that triggers these kind of events that will go back to the server and do all this. But integration testing, it just narrows that down to just the server itself and emitting all of those events that you would expect the client to emit without actually implementing the client and working with that. So I keep my integration tests at the application level because they really depend on that application. The integration doesn't work unless the application is pulling all this stuff together to work in an integrated fashion. We've already talked about the things like the episodes, shows, profiles, users integration, but this lives in the event integration module here. So you can see I have some utilities here. I've got a create socket helper function here. This is to establish the connection from a client side in a way similar to how your client is going to do it, but within the context of a jest integration test that's running within a build pipeline or something like that. But it's really similar. I'll go ahead and divert really quick over to this side. This is where this is an old side project of mine. I may continue it someday, I may not, but it's where I kind of cut my teeth on forming these patterns within Nest.js for working with event-driven approaches. And this is a React application that uses Next.js. And it's presenting a really like a command line interface that I was going to use for interacting with stories and enabling role play in this Storyverse application that I was working on. If you're interested, you can find it at github.com/bkonkle/storyverse. But essentially what I'm showing here is how I'm connecting my client to the WebSocket service here. So you can see I'm adding some event listeners here to handle the interaction that the user does with the web client. But really the big things here are the use store calls up at the top. That is using Zustand, which is a fun state management tool that's a little bit simpler and more straightforward than Redux, but it's the same kind of concept. And so in my Zustand events, I need to refresh my page here. In my Zustand events, this is my events.tsx file. I've got a similar thing as what we were just looking at in the integration test. I've got my create socket, and it uses socket.io or actually no, in this case it's using just WebSocket. I thought I was using Socket.io in the client here, but I'm not. I'm just using the built-in WebSocket support, which is cool, to set up my event listener for things that are happening in that communication with the server. So you can see it's listening for that message event that the WebSocket instance emits, and then it's starting to work with the type of events that we've been talking about in the gateway that we were looking at. So if you want more information about how a real world client might connect to something like this, take a look at Storyverse. But basically, I'm trying to do that same thing here within the build pipeline on the integration tests. So I'm using, let's see, what am I using here? I'm using, IO Redis, or IO Socket IO. Whew, too much IO. Using Socket IO here within the server process to connect to my my local host service that's been spun up behind the scenes by the whole Nest.js integration testing process that we've talked about before. But then this creates an actual WebSocket connection inside my testing container to do the things that I'm talking about. And it handles some common things like the connection being interrupted, let's retry it, etc. But there's nothing too fancy going on here. Dig into this and the client example if you want more information about how all this works. But ahead of time, I go ahead and clean out my database in tables that I'll be working with here. And I create my testing module based on the actual app module that includes everything like the Prisma, the roles and permissions, the event gateway that we're talking about. It sets it up in a real world way so that this is really like how it's running inside an actual production service. I'm making sure to set up my validation pipes and things like that. And then using Supertest to kick off that initial request that gets upgraded to WebSocket. I'm setting up some of my example data here, some of the user and show and episode instances that I'll be working with in my event interactions, and then setting up an alternate user so I can test things like censoring and authorization. And then we get into the real meat of things. This is when we're starting to actually emit events. So I've got my socket. This is the socket connection that we've established through calling that create socket function that we had seen above there. And then I'm going to go ahead and emit that client register event that we're expecting the client to send when they want to subscribe to a channel. And then you can see I'm constructing my register event up here with the episode ID and the profile ID that got created during the before all hooks. That's why this is inside a before all hook itself, because it needs to wait until those other async before all events finish up before the episode ID and the profile ID are available. And then it emits the event, and then it waits to see if the server sent back that client registered event. That happens at the end in the channel service. It happens at the end of that client register interaction. And so it uses this retry tool here. This is a utility that I use to take an async function and retry it over and over again until it actually comes back, or until it succeeds. So this will retry it 10 times. It'll wait to see, okay, did the server send back the client registered event yet? And if so, then it can move on and say, okay, does the client register event look like what we expect it to? Does it look like what the server is supposed to send back once it's acknowledging that it's subscribed to the channel? And if it does, then it moves on to see, okay, is it checking authentication? Is it checking to make sure that they're logged in? Is it checking to make sure that they're authorized? And then we move down to actually testing the message send interaction. So when a client sends a message that message should be echoed back to them because it's been emitted in a channel that they are subscribed to. So they'll get their own message back to them, and that's good. That makes it easy on the client side. You don't have to do the work of making sure that the user's message that they sent is reflected back to them, because that's handled by the Redis event bus behind the scenes. So what it's doing here is, first it's registering the client, making sure that it's subscribed to that channel, and then it's sending a message. And then if it sends a message, it should expect the server to emit a message receive event back to you with the message that you sent. This reserialize tool here is something that I've talked about in a previous video, but this just kind of sanitizes the JSON object so that the jest matchers recognize that it's the same object, typically by JSON stringifying it and then parsing it again to get rid of little complexities around classes and how they work in JavaScript. It's annoying, but it helps. But it's basically checking to make sure that the message was received with the sender that we expect it to be received with. And then it does more to make sure that the messages are being handled correctly behind the scenes, that it's being sent to other subscribers. And you can see it gets pretty involved because I'm setting up roles and permissions and things like that to allow authorization to pass and allow that other user to receive the event. And so what this is doing is it's actually, instead of checking to see if your own message was reflected back to you, it's setting up two separate connections at the same time, sending a message on one connection and making sure that the other connection, the observer, the listener, also gets that message like it's supposed to. And then it's checking to make sure that things like authorization are handled, or not having the profile that you expect, and runs through all the typical stuff that you would expect in an event interaction here. So I really like how this structure sets up a really kind of realistic, real-world structure for testing this stuff without having to go through all of the end-to-end stuff. Like, say we don't have a client yet. That other team is still working on that client, but we want to make sure that our server is doing what we expect the server to do. And this is a really good way to do that. All right, so we've been through quite a journey here talking about how to handle this event-driven interaction with WebSocket and Nest.js. Hopefully this has been really helpful. WebSockets and event-driven interactions can be really complex and really wild to wrap your head around. And Nest gives you a lot of tools to not only define your business logic and handle these events in a consistent way using some of the same tools that you use with your GraphQL operations or your REST endpoints, but also gives you a lot of ways to test these interactions and make sure things are happening the way that you think that they are. Check your assumptions. All right, I think I've covered enough for today. So hopefully you found this helpful. I'm glad I'm able to finally get another video out. I'm planning on moving forward with Rust. I've really found Rust to be my preferred next stack, the stack that I'm going to be shifting into eventually once I get everything ready, once I find a good market for it, that kind of thing. I really like the Rust programming language and how it provides a level of memory safety that it's just unheard of in other languages, and it kind of provides a hybrid of tools, borrowing from functional programming and object-oriented programming and other things to really handle some of these kind of things in a unique way. So my future episodes, I'll probably start stepping into some Rust episodes going forward, but I will circle back to Nest.js soon and finish up my series with a video on deployment. There's a lot of different ways to deploy, but if you look at the repository that I have my example caster code in, you'll see that I've set up a container-based structure for building my application. And so I'll talk about, okay, what's a realistic production-ready way to deploy those containers out to AWS, which is the ubiquitous kind of provider and cloud provider that everyone uses right now. How can I deploy this on AWS in a production-ready way? So be on the lookout for that episode. But like I said, I'll probably mix some Rust episodes in first, as I've been getting up to speed with that and really like it and really want to see more people using it for GraphQL, for real time for everything and beyond. Thanks for watching, and I hope you have a great day.